Welcome to JCE Connect. This video is on module 4. That in this video we are going to see the derivations which we have left from part 2, and we are going to solve few problems from part 2 and part 3. Means the derivation what we have solved in previous video, that is two derivations we have solved there. One is horizontal and vertical angle from the terrestrial photogrammetry, and one more derivation we have did in last class, that is in last video, is about the elevation of a point by photogrammetric measurements. So today third derivation I am going to do here, and we are going to solve few problems on derivation 1, 2 and 3. So this is part 3. As I said that this is the derivation third, and here we are going to determine the focal length of a lens. Now this experiment can be carried out by taking the theodolite and sighting two objects and then projecting the same on the negative, and you know that on the negative it will be a reverse image. So doing the analysis from the exposure station O with respect to the negative and the real objects on the ground. Now this is what we are going to do. But generally the focal length of a camera lens is given by the manufacturer. Since the accurate knowledge of the focal length is very essential, it can be determined experimentally as below. Then I have shown a figure. Now this figure will give you the details about the real image on the ground, means real objects on the ground, and the negative. So you can see that AB, capital AB on the ground, and negative will be having small ab, that will be in the reverse manner. Now here you can see that you will be having two objects. See here, this is object A and object B. You will be having theodolite, that what you are going to set here on exposure station O, or theodolite station, or you can call it as photo theodolite station. Then you are going to take the angles alpha A and alpha B with respect to A and B, capital A and B, which are there on the ground. And as we discussed previously that on the negative you will be having the reverse image. Here A is here at the downside and B is going to be there at the upper side. Now this is there, and the distance, see, from the negative, that is you will be having the principal point. See here, this is also a principal point, and here also on the negative also you will be having a principal point, small k. The distance between small k and O we called as what? This is the focal length. Now if you see this observation here, right? Now what are the things you will be having? You will be having here, see, you will be having small a, small b and k, right? The distance AK will be your XA. This is your XA. And the distance between B and K will be your XB. Here you will be having XB. And this is OK. Here it will be a focal length, that is, yes, that what you are going to determine, that what you are going to design. Now if you see here from O, if you sight A, now you will be getting angle alpha A, and from O you are sighting B, you will be getting alpha B, right? Then the total angle between AOB will be theta. Here this is the total angle, that equals to alpha A plus alpha B. The same reverse thing will be there at the negative. You can see that here this side you will be having angle B, and here you will be having angle A. Now selecting, as I said, that selecting 2 points A and B, measure the horizontal angle AOB, that is theta, that equals to what? Alpha A plus alpha B, and that you have to determine by using theodolite. Let XA and XB be the coordinates of the 2 points. Then we have BK is equal to XB and AK is equal to XA, that what I have shown you. Then in previous class we know how to determine the vertical and horizontal angle. There we have seen the tan alpha A is equal to XA by F, and tan alpha B is equal to XB by F. Now this tan alpha A and tan alpha B, this reference we have to take from derivation 1 of a previous video, where these two are the horizontal angles, right? So there we came to know that tan alpha A is equal to XA by F and tan alpha B is equal to XB by F. Now if you multiply tan alpha A with a tan alpha B, then tan alpha A into tan alpha B is equal to XA by F divided by XB by F, that you can write XA XB divided by f square. This is what I am showing. Now from angle AOB, what you will be having tan theta, as I said that theta is equal to alpha A plus alpha B, then tan theta is equal to tan of alpha A plus alpha B. Then tan theta, if you expand, see here tan, right, A plus B, if you take a trigonometrical function, if you expand this tan A plus B, how you are going to expand it? Tan A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. In the same manner we have described here, we are going to use that function here as tan theta is equal to tan alpha A plus tan alpha B divided by 1 minus tan alpha A into tan alpha B. The same way you can you can subtract the values what you will be having here with the tan alpha A and tan alpha B into this equation. We know that tan alpha A is equal to xa by f, so here this will be xa by f plus tan alpha B is equal to xb by f divided by 1 minus xa xb divided by f square. Now this equation, from this equation you are going to extract the f value, right? So the same thing I can write in this fashion also. I have shown you here that tan theta is equal to 1 by f into xa plus xb divided by f square minus xa into xb divided by f square. That is totally, that denominator will be f square minus xa xb divided by f square. Now if you if you cross multiply all these things, you will be getting, see here, that one is going to be that f here, 1f is going to cancel here, then you will be having 1f will be there, then it is going to be xa plus xb divided by f square minus xa xb divided by f. Now you can take that f here, right? You can take that f here, then f into xa plus xb divided by f square minus xa xb. Now from that last page, tan theta is equal to f into xa plus xb divided by f square minus xa into xb. Now I can take this term, right, this term here to this side, so it will be, see what is going to be, tan theta into f square minus xa xb, that equals to f into xa plus xb. Or I can write that in this fashion also, see, f square minus xa plus xb into f divided by tan theta minus xa xb. It means that I am converting this whole equation into the quadratic equation. So that quadratic equation, you know that is ax square plus bx plus c is equal to, right, 0. That in the form you have to get this equation. Now once if you get that equation, then the final result will be very easy. See here I have shown that the value of x, how to get that you already know that is x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. The same way you will be having here that which gives you the application of quadratic equation here, that which gives you the f is equal to xa plus xb divided by tan theta plus square root of xa plus xb whole square divided by tan square theta plus 4xa xb divided by 2. The same thing I can write in this fashion, that what I have shown you here, that is f is equal to xa plus xb divided by 2 tan theta plus square root of xa plus xb square divided by 4 tan square theta plus xa xb. Now here this is the formula that you are going to use to determine the f focal length. Thus the value of f can be calculated. Now by using all three derivations, derivation 1 and 2 from the previous video, and here in this video we have seen derivation 3. By using all three's derivation, we are going to solve few problems. I opted two major problems, two important problems from the set of problem. So here first you should understand the data, then you are going to check how to solve that problem. Now here you can read, I'll read that, you can see that the problem. I'll read this problem first. 3 points A, B, C, capital A, capital B, capital C were photographed, and their coordinates with respect to the lines joining the collimation marks, means the principal lines on the photograph are, see, they have given the points and they have given the coordinates, right? So here see point A, point A. Now this point on the photograph, it is located, so along the x it is having minus 35.52 mm, along the y it will be plus 21.43 mm. Now if you see point B on the photograph, it will be plus 8.48 mm and it will be minus 16.38 mm along the y direction. For C, point C, see the data, it is both the directions x and y are positive. So here you will be having x direction, x is equal to 48.26 mm and here you will be having 36.72 mm along the y direction. The camera axis of the camera was at level. The time of exposure at the station means at the O, that what they have given here. Now the same problem I tried to explain with this figure. This figure is not given in the problem, but I had drawn it here with the data only so that you can easily understand the things. Here these are the x and y coordinates. See, you know that to get the angle, horizontal or vertical angle, you should know xa and xb, ya and yb. Say xa xb, ya yb, then xc yc, these things you should know. So I drawn a figure here just to understand the things. Now here see that first and foremost thing that you have to understand the, see if you take any quadrant, right, and if you take this as a y and this as a x direction, so you'll be having 4 different coordinates. Now in first quadrant you will be having both plus plus, then in second quadrant x will be positive where y will be negative, and in third quadrant you will be having x as negative and y will be positive, right. Third quadrant I'll show you, x as negative and y will be negative. Both will be negative in the third quadrant. X is negative, y will be negative. And fourth quadrant you will be having x as negative, y will be positive, right. This you have to understand, right. In first quadrant both are positive, x and y plus plus. Second quadrant x is positive, y is negative. Third quadrant both are negative, and in fourth quadrant y is positive, x is negative. Now with this understanding, say I have drawn the figure here. So I have taken the A. First we'll see A. See A, x is negative means it is going to come this side, and y is positive, so it is going up 21.43. So here you will be having point A. This is the marking of point A, location of point A. Similarly here B is going to be, see x is positive, y is negative, so it is going to be into second quadrant. Now here see this, x is 8.48 mm in this direction from center and it is going down for minus 16.38, so you will be having B point, right. Similarly you have to locate the C point on the photograph. Both are positive means it is going to be in the first quadrant, right. So this is what you have to understand. Once if you understand these things, then remaining thing will be quite easy. At the end, see what they have asked. The focal length of lens is given, that is 120.80 mm. Determine the azimuth of a line OB and OC if that of OA is given. Azimuth of line, that is A is given, that is 354 degree 30 minutes. Now to determine the azimuth of any line, you should first get the horizontal angles, that is alpha A, alpha B and alpha C. Once if you get the alpha A, alpha B, alpha C, you can easily determine the camera azimuth. By using that camera azimuth you can determine the remaining azimuth of line B and C, right. So first and foremost thing is that I am going to determine the alpha A, alpha B, alpha C. So here from the position, see tan alpha A is equal to XA by F. We know that in the you can take the reference of derivation 1, right. In derivation 1 we have got that horizontal angles tan alpha A and tan alpha B, right. So XA, tan alpha is equal to XA by F. So XA is minus 35.52 divided by 120.80. This is XA is given, right, for A's location, right. XA is known, so F is also given, that is 120.80. you will be having tan alpha is equal to minus 0.294, where tan alpha is equal to tan inverse of minus 0.294, then alpha A is equal to minus 16.383. Now you just press the you will be having a button there on your calci to convert the value into the degree and minutes. As you press that, you will be getting 16 degree 23 minutes. Now to get the alpha B, tan alpha B is equal to XB by f, that xb is known, it is given in the problem, and also f is also known. So it is xb is positive 8.48 divided by 120.80. Then tan alpha b is equal to 0.070. Tan alpha b is equal to tan inverse of 0.070. Alpha b is 4.015. If you convert to that degree, it is going to be alpha b is equal to 4 degree, that is positive 1. Now tan alpha c, same way as alpha a alpha b, that is xc divided by f, that equals to xc, we know that it is a positive one, so c lies in the first quadrant, so both are positive, so xc is also positive, that is plus 48.26 divided by 120.80. Tan alpha c is equal to 0.399 and alpha c is equal to tan inverse of 0.399. Alpha c will be getting 21.77, whereas alpha c, now if you press that degree minute second switch into the calci, you will be getting the alpha c is equal to 21 degree 47 minutes. All angles are, see here, alpha a is equal to negative, that is 16 degree 23 minutes. Alpha b is positive, that is plus 4 degree 0 minutes. Alpha c is also positive, that is 21 degree 47 minutes. Now we are going to the step 2, that is our main intention, to find out the azimuth of different lines. Now before going to the finding out the azimuth of different line, you should find the azimuth of a camera axis, right? Because camera axis is going to help you to determine the azimuth of different lines. So first we are going to determine the azimuth of camera axis. Now these also we have seen in the first video, few important notes I have given, and these formulas I have written there. If you want, you can go to that video and just check it out. Even in PDF what I have seen in the last video, that also you just check it out. Now here azimuth of camera axis, that psi is equal to psi a minus alpha a, that psi a is given in this problem, that is 354 degree 30 minutes, minus of minus, alpha is minus, so it is minus of minus 16 degree 23 minutes. Now if you add all those things, because here it is minus of minus, so it is going to be adding, so you are going to get the 370 degree 53 minutes. Now 360, it is more than 360, so you have to deduct 360, you will be getting psi as 10 degree 53 minutes. Now this is your azimuth of camera axis. By using this, we are going to find out the remaining azimuths. Now here see azimuth of b, that is psi b is equal to, that equals to psi b is equal to, see azimuth of b is equal to psi, that is camera azimuth plus alpha b, right? The 10 degree 53 minutes plus 4 degree, you are going to get 14 degree 53 minutes. Similarly, you will be having azimuth of c, psi c, that equals to camera azimuth psi plus alpha c, that is 10 degree 53 minutes plus 21 degree 47 minutes, so you are going to get the 32 degree 40 minutes. So that you can call it as pi or psi, that the way you are going to use that notation, you can use it, right? So there may be the change in the pronunciation or calling that particular symbol, so I use it as a psi, so I am telling it as a psi. So here I got both the azimuth. This is the problem, that the main problem, it is going to come into the examination, so you have to be careful to handle it. It is quite easy, so please practice this. So now we are going to go for one more problem you have to solve, so we'll see that problem now. Okay friends, so let's see the second problem. The distance from 2 points on a photographic point to the principal line are 68.24 mm to the left and 58.48 mm to the right. The angle between the points are measured with a transit is 44 degree 30 minutes. Determine the focal length. Now here xa and xb means x1 and x2 are given, right? I hope you remember the focal length formula. So that formula we are going to use here. So in that formula you will be having xa and xb, right? So here I am taking it as x1 and x2, right? So both the values they are given, and along with that the theta value is also given, right? So theta is 44 degree 30 minutes. So it is very easy, you just use the formula. Here I have written the formula, that is f is equal to x1 plus x2 divided by 2 tan theta plus square root of x1 plus x2 square divided by 4 tan square theta plus x1 x2. Now if you clarify the things, so I have written what are those things, where distance of first point from principal line x1 is equal to 68.24 mm. The distance of second point from the principal line x2, that equals to 58.48 mm. So this is x2 and x1, both are there. Along with that they have given the theta, that is 44 degree 30 minutes. Now by using all these you can solve this problem. Now from the above formula we know that if you clarify the terms, right, I'll just simplify the terms. So first term, that is x1 plus x2 divided by 2 tan theta, that equals to 68.24 plus 58.48 divided by 2 into tan 44 degree 30 minutes, that equals to 64.47. Before solving, it is very good thing that you clarify the formula. See, I'll tell you first the way to solve the problem. First write the formula, what I did here, then just clarify the things, what are those things, as I did here, that x1 is equal to 68.24, x2 is equal to 58.48, and then theta is equal to 44.30, the 44 degree 30 minutes. Just clarify the things, then separate the formula. You can, if you want, you can bifurcate, or in a one shot you can solve this problem by using that formula. Put all the values in the problem and get the answer. But what I did here, that I just simplifying the things. I'm taking out the first term, that x1 plus x2 divided by 2 tan theta, that equals to, see here I have put all the values and I got the 64.47. Now I'll go for the second term. Now see here, x1 plus x2 divided by 2 tan theta whole square, that term if you separately segregate, that is x1 plus x2 divided by 2 tan theta is nothing but 64.47, and whole square of that is 4157.10, right? Here it is. Okay, then x1 x2, I'm just clarifying the things, simplifying the things, right? x1 x2, x1 is 68.24 into 58.48, 58.48 is x2, so you'll be having 3990.6 here, right? Now all together if you put in the formula, you'll be getting, what you'll be getting, see here, you'll be getting f is equal to 64.47, that is first term we have seen. Then second term, directly I'll be putting the values here. So square root of 4157.10 plus 3990.6. So you'll be getting 64.47 plus 90.26. So f is going to, f is equal to 154.73. Now this is the very simple problem, and these are the important problem. Most probably they are going to ask these kind of a problems only. So I just opted these two problems. Now friends, before closing this video, I'll just clarify the things. The previous videos of this module 4, the first video, that is part 1, is all about the aerial photogrammetry, and there we have seen the all kinds of aerial photogrammetry, different the definitions and all those things. Then part 2, that is terrestrial photogrammetry, and a few derivations we have seen there in the part 2, and this is the part 3. And this is part 3, where we are having the remaining derivations. See, in part 2 we did a few of the derivations of terrestrial photogrammetry, derivation 1 and 2, and in this part 3 the remaining derivations of terrestrial photogrammetry and the problems we have solved. So part 2 and 3 are going to be all about the terrestrial photogrammetry. Now the part 4, that is full shot of aerial photogrammetry, means there we are going to derive 2-3 equations, and then we are going to solve few interesting problems of aerial photogrammetry. Now that is what all about the aerial photogrammetry full module, right? And this is what from my side. If you are having any doubt, please let me know, contact me. You are having my number, you are having my WhatsApp number, right? So you can text me out. Just try to solve these kind of problems. So stay tuned. This is what from my side. I am Professor Bayasab Jamada. Thank you.